Hello everyone. Today we are going to learn about first module of mathematical foundation of actuarial science. It's introduction to probability. So the outline of this module, first you are going to learn about basic terms we are going to use throughout this course. So it's going to cover under the probability model. Then we are going to learn about sets. And then finally, we are going to do some example problems from Society of Actuaries example problem list. So first thing, we are going to learn about the elements of probability model. A probability model has three essential elements. The description of underlying probability experiment, outcome of the experiment, and a rule to assign numbers between 0 and 1 to subsets of outcome. Now remember that probability should be between 0 and 1. So whenever you have outcomes from probability experiment, you need to have a rule how you are assigning a number between 0 and 1 to those outcomes. And there are several keywords you will hear throughout this course. First one is probability experiment, then outcome, sample space, events, and axioms of probability theory. Probability experiment is a test that allows us to measure possible experiment results or outcomes. Usually there are more than one possible result from this experiment. If there's only one possible outcome, then the probability would be always 1. So because we have more than one possible result, we have to use the probability to estimate how likely this outcome to occur. There are several methods we can use to calculate that probability. We are going to learn those methods over the semester. Outcome is a single experiment result called as outcome. So when you conduct a probability experiment, there are many possible outcomes. For example, if you toss a coin, it can be either head or tail, but only one is going to occur. It can be either head or it can be either tail. So that single possible outcome is called, single possible result is called as outcome. A sample space is a collection of all possible outcomes. An event is subset of that sample space. So when, for example, if you toss a coin and if you collect all the possible outcomes, head and tail, that's sample space. And if you take only one subset of that, let's say head, that is event. Another example would be, let's say you roll a die, and then the possible outcomes are 1, 2, 3, 4, 5, or 6. You can define event to be like the phase would be even value. So then the subset of this sample space, which is 2, 4, and 6, is called as event. These the single the experiment result, those are called as outcomes. Axioms of probability theory. The first one is probability of any event should be between 0 and 1. Probability of sample space, in here I use U, or sometime you will see S. Probability of sample space need to be 1 because something in that sample space need to happen. Now, if you have set of collection of events which mutually disjoint, we will discuss what that means. Then you can calculate the probability of the union of those events as sum of probability of individual events. So this is called as axioms of probability theory. Next, we are trying to distinguish between discrete probability models and continuous probability model. A discrete probability model means you can enumerate or you can count outcomes like outcome 1, outcome 2, so forth. In continuous probability model, you cannot count because outcome is uncountable. For example, let's say you toss a dart at unit interval 0 to 1. then you cannot really write down all possible outcomes. So that's constitute the continuous probability models. Next, you have equal likely outcomes. That means any outcome in sample space is equal likely to happen, or the probability of occurring any outcome in that sample space is equal likely. When that happens, the probability of occurring a given, like a single outcome, is 1 over n. N is the number of outcomes in sample space. So if you have equal likely outcome, then you can calculate the probability of an event. The idea is event is subset of sample space. So what you do, you count how many outcomes in the event. You divide it by the number of outcome in sample space. That gives you the probability of occurring of that event. Here you can see an example. This one says toss 3 pair coins at the same time. And they assign numbers. If it is head, 1. If it is tail, 0. And the question is, how many ways will the sum of result be exactly 2? So we can write the sample space, all possible outcomes. So first one is head, head, head. Then head, head, tail. Head, tail, head. Tail, head, head. Then you can have 2 tails. So head, tail, tail. Tail, head, tail. Tail, tail, head. Then the last one you can have all 3 to be tail. So this is our sample space. Now they define an event here, sum of result exactly 2. So you're assigning head 1, head 1, head 1. So if I add the sum of result for this outcome, it's going to be 3. Okay, when you add 1 plus 1 plus 1. For this one, if I add 1, 1, 0, because you're assigning 0 to tail, you would get 2. Okay. So then we can see that our event, sum of result exactly 2, is going to be this. We need to have 2 heads. So then the assuming it's fair coin, or the fair word used for equal likely, we can calculate the probability of occurring that event E. So that's going to be number of outcomes in event E divided by number of outcomes in sample space, which is 3 over 8. Another useful tool in probability, when calculating probability, is tree diagrams. Especially if you have multi-stage experiment, you can use tree diagram to calculate probability. I assume you have seen a tree diagram before this class, so they look like this. We are going to do one problem and understand how to use tree diagram. So here is an example. You can see that question says, first you roll a pair die, and next you toss a pair coin, and then use a tree diagram to list all possible outcomes. So the first one is pair die. That's the first stage. So these are the possible outcomes. It can be 1, it can be 2, it can be 3, or 4, or 5, or 6. Then the next stage is you are tossing pair coin. It can be head or tail. So now the way we calculate probability here, assuming pair die and pair coin, you can see that the probability of occurring any of these 1, 2, 3, 4, 5, 6 is 1 over 6. One outcome out of 6 possible outcomes. Then the pair coin, 2 outcomes. There are 2 possible outcomes and 1 to be occur, 1/2. So head is 1/2, tail is 1/2. Now the way you calculate probability is you multiply probability across branches. For example, if I want to calculate probability of head and 1, that's going to be 1/2 times 1/6. The same way here, if you want to calculate probability tail and 1, that's going to be 1/2 times 1/6. So that's how you use the tree diagram. So that's for the first part of the module 1. Let's meet again in the second part of the module 1.